make annotations on maps, integrate with an AI optimization engine, and see our new scheduling function. If you want to find out more about the new additions to Formbird, stick around. This is Formbird at Work. My name's Paul Hosking. Formbird at Work is a new series of meetups where we hope to share the latest functionality with the larger Formbird community. As Formbird spreads its wings into new industry spaces and different types of organisations, we continue adding cool things we want to share. Unlike our industry-specific meetups, this series, I guess you could call it a bit of a show and tell. Mark, why are we having a show and tell?
Okay, guys. Thanks for everyone for coming and those watching us on video. Look, the idea here is that we're always, I suppose, internally showing and telling to each other what's going on or what we've done. And the idea here is to show and tell what the platform is capable of in some of the specific areas that we're developing. And they may be shown in different applications, but as we know, the architecture of our platform is that it's incredibly modular, incredibly plug and play. So the idea here is to have cross-industry exploration of these functions, so that if it's seen in one application, maybe there's triggers something in another application or another business that makes sense. So it's part of just showing what we're doing as an organisation from a technology point of view, but it's also from a business point of view, because they will be point solutions, if you like, or point elements within various applications that form an interesting component or element of that application that, as I said, may have some cross fertilization into another industry or another application.
Yeah. So it really is about us sharing a bit of our process as well as our function. And because not just about look at this new toy, it's about how do we come up with that new toy? Who was the person who suggested it and why did they suggest it, and how we came to the conclusion to actually put that function into the application. As a reminder, just to everyone who's here and people who are not, we have all our videos on our YouTube channel, which you can access via our website, formbird.com. And you can drop us a like. Even if you're watching this halfway through, drop us a like. Make sure you have your say, make a contribution. If you've got a question, don't have to put up your hand, just yell. If there's something that is sort of burning on your mind, but you don't think this is the right place, just pop it in the comments section or in the chat. What's on today? So we're talking about map annotations. We're going to have a look at constraint-based optimization. Adam is going to present on integration with an AI optimization engine and how that works. Super new. Everyone wants to talk about optimization and AI nowadays, so we have to. And Paul has an amazing scheduling function that he's going to show us all. Grant, he's one of our young guys, our great Formbird consultants. Grant, would you like to take over and tell us a little bit about the annotations on maps?
Yeah, sure. So for those that don't know me, I'm Grant Randall, and I'm working on the Greater Western Water Clarity application. And what I wanted to talk to you today was about how we're uplifting some of the standard components in the platform in response to customer requests for new functionality. And when that happens, that gives an opportunity to all the other applications out there to be able to maybe pick up that component, pick up that new functionality, and use it to power up their app a bit more and get more out of it. So the example that I wanted to talk to you about is a request that came from Greater Western Water to do with GIS amendments. And I'll just share this screen. Try this first. Here we go. Share. So just drag this over here so I'm talking to you. Okay, so this is a process that exists today in Greater Western Water, or City West Water. When they find something out in the field that doesn't match up with their GIS system, and what happens today is somebody goes and fills in a paper form, You can see it's all handwritten here, and does a little sketch to show, what needs to be modified in the GIS system to bring their asset information in line with what's actually out there in reality. They might include a photograph. They might actually take a screenshot out of the GIS and annotate it. There's a couple of different examples here. This is a kind of a fairly simple one that someone's done a sketch on. And you could sort of see there might be some problems with this. There's, the paper actually has to make it from the field to the depot desk and then ultimately through to headquarters, lands in someone's in tray, and eventually it gets processed and an update's made in the system. In parallel to this, when the actual work's being done in the field in Clarity, someone ticks a little box and says, oh, an amendment was made. So there's a parallel system that they're using to track to make sure they hopefully get these bits of paper, and hopefully they then update their GIS system. So not a particularly efficient system, as you can probably gather. So what we wanted to be able to do was to where's that share button gone? Just hang on a tick. What we wanted to be able to do was to allow the user to make those annotations within the Clarity system and then assign a task directly to the administration team so that they could make the update in the system, and we can close the loop on this process. Here we go, stop share. Okay, so that was the request from GWW. Now, what we realized was we had a component, and I'm going to show you that now. If I share this one, here we go. Over. So, yeah, so we have this. Hopefully, you can see that well.
Yep.
Yep. So we have this. We have this existing component that can display and can be used to draw simple things. We can draw a line. Well, I actually haven't tested this one out, but anyway, suffice to say that it had some very basic functionality to be able to draw some shapes. And what we wanted was something that would allow us to put text boxes, maybe drop some specific icons, to be able to do an arrow and do a few different things, maybe add some dimensions like the dimensions that you saw. Now, this component that we had, this basic component, didn't have that functionality. So the development team, the component development team, did some work and added some drawing tools. So I'm going to show you this, and this is still a bit of a work in progress. So this is giving you an idea of the process by which this stuff comes about. So I now have this additional drawing tool palette. It gives me some things I can now draw, like an arrow. And if I wanted to, for instance, if I was doing a council application instead of maybe my application that I'm doing for Greater Western Water, I might want to say something like, just move this in. I might want to say, oh, I was out doing some work and I saw that there was a branch that fell off this tree here. And so I might say, I want to put in a note here that says, branch to be removed from tree. And then I might want to put an arrow, highlight this tree. Oops. There we go. And then I might want to be able to do some other things. I might want to mark something up. Oh, look, there's fish falling from the sky. So we've got a few fish that are...
So this is an introduction yet, is what you're saying, Grant?
Yeah, so this is kind of general functionality that's now been added to this component.
Yeah.
So that we can... oops. So there's a squid as well.
Yeah.
So
to be clear, there won't be this squid.
Yeah. So this is very general functionality that's been added to this component, which could be used for my application that I've described, or it could be used for, like I said, something like a council application if you wanted to be able to annotate and use a satellite view to show exactly where some work needs to be done, or to be able to drop particular icons into a map somewhere, and they stay located with the map. They size even when you zoom in on the map. They stay sized with the map so you can still read them. So it's quite nice functionality. So having got that functionality yesterday, you wanted to ask me something, Paul?
No. I was just saying, yes, this is really impressive, and I can see how this would be used in all sorts of different industries or organisations for all sorts of different things. But specifically in Western Water, it's often about changing the way pipes work. In Greater Western Water, it's about changing the way pipes work.
So then sort of taking it on one step from there, if I can find that again. Yep. So yesterday I started on this project. Now that I have this functionality basically available, I started working on this new form for Greater Western Water. So I spent about 3 hours building this form yesterday, adding in the sorts of information that they want from it, a reference number. This will be a table that shows outstanding records that need to be worked on. And so for a start, we might put in the address. This is the way that Greater Western Water go about it. I might select a pipe. This is the pipe that, for instance, is out of location. Now, what's intended to happen is this is the automation that still needs to be added to this form, but it will pick up the existing information we have about that pipe and pre-populate it. So if there's some information that they want to adjust, they can edit that directly. Maybe they want to change the material because they observed it was a different material. So we can do that. And then this is where I've added our new component where we can do our sketch. So when the automation's added, it will actually zoom in onto this address that was previously entered in the previous map, and then I can start to draw. I can start to draw things. So yesterday I added the icons that represent the different types of assets that are important to Greater Western Water. Nodes. These are the symbols that are used by convention throughout our maps. There's a couple of special ones here. So maybe this is a water electrolysis point. So I might want to drop a water electrolysis point here and show this is this is the location of the new electrolysis point, for instance. And I might want to give a little bit more information. Okay. I might want to say give a dimension from the corner, so the street to the new point. So we can do that. So these are some of the features that we can add. What else do we have? One feature that's not quite implemented yet, but still in work on this component, will be that you'll be able to draw a line by standing at a particular location and dropping using the target, and it'll drop the point at the GPS locations, and then you could move to the next location and drop a point. So you could depict a dimension that's based on the two GPS locations of where you were standing at the time. So you can see that would be quite kind of useful functionality for a crew. Essentially that's sort of given you a bit of an overview of how a customer request has driven an uplift to the entire platform capability for Formbird that's now available to anyone to use in any application. And you've also seen how it's beginning to be implemented in the Clarity application for Greater Western Water to fulfil their request.
Mark, what is constraint-based optimization?
Okay, just as a quick introduction of what constraint-based optimization. So as an organisation, we're working heavily with Opturian. Opturian came out of a couple of Monash University projects and CSL and a couple of other, not CSL, CSRO. So the constraint-based optimization is where you take any number of constraints and it tries to optimize the position or the final solution. The difference, I suppose, of this technology is that historically constraint-based optimization was a linear process where it'd be trying and attempting different scenarios to just try and get a certain value. The uniqueness of this optimizer is that it's actually trying to land on positions and then better its costing on each position, which means that what would otherwise be an unsolvable solution, it'll come to a solution. It may not be the best, and the longer you let it run, the better the solution it'll go. And when you're actually looking at the optimizer trying to perform an ultimate result, it'll be in a logarithmic sort of approach, and then suddenly it'll drop out, and the actual costing return may be wild because it's gone and tried a set of parameters that it didn't actually end up with a nice result. The optimizer actually looks at a common value. So when you're optimizing, you can optimize, say, on time. So everything you're trying to optimize against that will be based on time. How do I get the shortest amount of time? Quite often we do it against dollars, and the dollars are really just reference dollars because time can typically be translated into dollars. The labor time for a person or a truck or whatever else can always be equalized out to dollars. So dollars is a good one, even though the optimizer doesn't care what the final dollar value is. What the optimizer is doing is trying to minimize that dollar value by shortening the route, by shortening the time the vehicle's on the road, by shortening the distance between them, et cetera, et cetera. So, and you can end up with, you need certain constraints, but you can't over-constrain. If you over-constrain, then the model actually fails, because if there is a constraint where there's only one solution, then it becomes that you can't actually optimize in the end because you've only got one solution in the end. So there is a balance on when you're designing an optimization situation that you have got enough degrees of freedom to actually end up with a optimized result. If you sort of say that there's only one place a truck can go and you're saying, I want to optimize a route, well, there's not a lot I can do other than just go to that one spot, by example. So, constraint-based optimization is putting a whole lot of constraints into the system and saying, this is what I want to try and optimize, and then look at that final solution. And the uniqueness of this solution is that it's a non-linear approach to it. We can run a few examples, but we'll let Adam do the example. And if there's any questions at the end, we can talk about it.
Thanks, Mark. I know for a lot of people that's sort of like, I just wanted to make sure that people can come back and say, well, what is constraint-based optimization? And there is the answer. Now, the process of the integration, a bit about why the integration. A bit about how the integration is helping the organisation.
Exactly right. And thanks, Mark, for providing that explanation about constraint-based optimization. I definitely couldn't have done that justice. I will talk about integrating the optimizer. So there's two parts to this. There's the constraint-based optimizer, which Mark has explained there, but we also have the integration aspect of it. And just in really simple terms, an integration is just connecting to one application to another application, so that information or data can be transferred between them in really, really basic level. So to demonstrate some of the benefits of actually constructing this integration with the optimizer in this case, I'll talk about a mobile speed camera deployment project that we've been working on over the last 12 months. So in this case, the constraints, if you like, for the optimizer were a certain number of sites that needed to be visited, that the mobile speed camera operators needed to take their vehicles and set them up. You've got the actual number of vehicles that we have available to carry out those tasks. And we've obviously got the people to do it as well. So specifically their time. So when they're available to carry out the tasks. They're the kind of main constraints in this particular project around mobile speed camera deployments. So to help me explain this particular integration, there are probably three main aspects that you need to be aware of. The first one is the process of actually scheduling which sites to visit when and where to meet the given KPIs that are set out. So, you want to hit 1,000 hours, say, within the month, and you want to hit, 200 sites, and you've got 6 vehicles to do it. So they're the kind of constraints that could go into the optimizer that they optimize on, and the optimizer spits out a result that meets those conditions in the best way possible. So that's where Opturion's optimization comes in. The other parts of this project was actually providing information to the fingertips of the operators so that they can carry out the work. So telling them which site they need to go to and when, and allowing them to collect information about what they've done as well, to say that they have completed it or to say that they weren't able to for some reason, and collect information around those processes. So those second two parts, providing that interface for the operators and the administrators, was where Formbird came into the project. So initially, the customer actually engaged Opturion for the optimization part, and then subsequently involved Formbird for that user interface. So from early on, we intended to do this integration, but the project timeline really meant that we weren't able to straight away, and that we needed to prioritize getting the two systems running independently, and then revisit the integration once those were stable, and the operation was more stable as well. So what I'm going to do is to talk about that process that they were using before we did the integration, and then what that process looks like now after the integration. So before the integration, for the client to use the optimizer, they needed to configure all those constraints within a spreadsheet in a certain way that meets the optimizer's requirements. They would then use the optimizer, send that spreadsheet to the optimizer. The optimizer would do its work, run through all those iterations of possible solutions, and then spit out what it thinks is the best solution for that whole 30-day period, for example. So they would provide that in another spreadsheet as well. So the user was really interacting with spreadsheets to get the optimizer to run. And then in parallel to that, we also had our application providing that interface. So there were a couple of key issues there that were apparent when we were operating in that stage where we had the two systems independent of each other. The first one, the customer needed to manage that complex spreadsheet, but they also needed to, for the input to the optimizer. But we also were in the situation where we had to actually duplicate a lot of the data, manage those two data sets in parallel, because the optimizer actually needed, information about the sites and the vehicles, to run the optimizer. But we also needed that within Formbird. So the customer was needing to manage those two sets individually. And I think this is really common across lots of businesses. Certainly our fleet customers experience this a lot with, you have your fleet management system, but then you also have your finance management system that all, record details about assets, but they don't talk to each other. So you're trying to keep the two systems, in line all the time. So that was the other big problem that they really faced. So then, once that application became more stable and we, developed the base application that the operators were dealing with, and the optimizer was working the way it needed to, then we've since revisited that integration and we've actually developed that now. So really now what it looks like is we've essentially reconstructed that input spreadsheet that they were using within the application, not in the same way, but in achieving similar outcomes. So I'll actually stop and share my screen now, so you've got something to look at and you're not just listening to me yak away. It's a bit tedious. So just bear with me while I screen share here. All right, can you see my screen now, everyone?
Yep.
Is that okay?
Yep.
Perfect. So as I said, we've taken that input spreadsheet that the client was using, and we've reconstructed the equivalent functionality within Formbird. So you can kind of see this here. So there was all these constraints around, how long it might take to set up your vehicle at the site. You've obviously got all your site details as well. So, which types of vehicles. So we had SUVs and trailers, which types of vehicles could go to which places, where those places were. They're the kind of constraints that we were dealing with, the resources that we had available. So those vehicles that we had available as well. They were all the constraints that we were dealing with. So we recreated that in the application. So the benefit of this really is that instead of managing those two data sets in parallel, what we're actually doing now is we're housing all of that data in Formbird as a source of truth and just populating this particular area of the application with that data. So the sites are all in the one place in Formbird, and the input sheet here is just populated with that information. The other thing that building this within the application has allowed us to do is build in those business rules to the application to help guide the user into constructing a input, if you like, for the optimizer that meets those business requirements, but also meets the rules that are set out by the optimizer, you know, what the optimizer will accept. So all of that is built into this integration so that it all works well for the user and is as intuitive as possible. So once the user actually configured this in the right way, and I'm obviously not going to go through all the minute detail of that now, but once all that data is in here and configured in the right way, the user simply clicks this button here, which runs the optimizer. And what's really going on in the background here is that we're getting all this data that we've collected here, making sure it's constructed into the format that the optimizer requires for their input. We send it through a component web service. I don't really understand how that part works. Smarter people than me develop that stuff. But we send it through that component web service. The optimizer receives it in that system. They do their work optimizing it. We can show the progress of that optimization as it's running. It usually takes a little while to run, in this case. And then once it's done its work, we get that solution back from the optimizer and we can reconstruct it and present it to the user within the application. So the user is never having to leave Formbird to engage with Opturion's optimizer. So we run the optimizer. I'm not going to do it now because it does take quite a while, but I can kind of show you all the steps. So once we've run the optimizer, we get all of the solution back again from the optimizer. And the main output here is what we've called the solution run sheet. And this details all the individual tasks, you know, where the operators have to start, where they need to go to, and when they need to go there, how long it's going to take them to set up. So the operators have all that information at their fingertips. So this is really presenting all this information, the solution from the optimizer to the person organizing the schedule, so that they can review what the optimizer has spat out, essentially. Once they're happy with this, then it's as simple, again, as clicking a couple of buttons, and then you can click the create tasks from run sheet, and this creates the actual entities that the operators will engage with in the application. So your tasks, if you like, where they can go in, see where they need to go, see specific information about the site, record what they've done or what they haven't done, and then administrators can see that progress. So clicking that button here creates all of these individual tasks. In the fleet application, you know, they're kind of equivalent to requests or work orders, I guess. That's enough screen sharing. One second. One example about optimizing, but a couple of other examples of integrations more generally. So Josh, another consultant here, is also working on a similar project to this project around Hills Tankers and Opturion, the bulk fuel transport. So they're doing that work. And we also have other integrations. Paul has built integrations to Geotab. And we've also got Dial Before You Dig in the GWW Clarity water app as well. So there's some other examples that we've done around integrations. Just to sum up, I guess, the main benefits, you know, we've eliminated that whole spreadsheet process for the client. So they're really saving significant time now, that they were spending troubleshooting that spreadsheet and constructing that spreadsheet, all of that data. That's now eliminated. So they're now able to spend that time, you know, increasing efficiency in other areas of the application and their operations. That's kind of the key benefit, if you like, of completing this integration work.
Well, the best for last or something like that. Paul, can you tell us about your new scheduling tool, and why it's so good?
I can try. So let me just share my screen.
So Paul is I'm going to call him senior developer, rather consultant for Formbird, and has done a lot of work with Fleet. And this is also, I think, part of Fleet. And he's going to show us what it's all about.
Yeah, so Grant and Adam have both mentioned components and integrations, and they're critical parts of Fleet as well. all the applications are built on components, and as Grant was saying, as they improve, all of the applications improve. I reference components as kind of like bricks, so you can build your application like Lego bricks, and you can, like old school Lego bricks, I guess, not the new school ones, the bricks that are 4x2, and you can build your application with 4x2s and get to a really nice point. But at some point along the way, you might need a brick that you don't have. That brick is probably more like the newer Legos, where they're shaped to do specific things on models. And so that's what I'd like to talk about today is when you get to a point with your components and you're building your forms and going, okay, well, this component doesn't quite do what I need it to do. What are the options then? How do I move forward? And then how does that move back into the application at a later stage? So with that background, I've been building a asset booking calendar, and this is basically so that people can book cars out to use throughout the day. This form that you're looking at here is part component. It's all component. Some of those components I built specifically for this particular application, using a basis of external libraries, etc. So just let me point out. So these are our SC components. We've got a drop down for asset, a drop down for who requested it, mobile phone number, bookings. This section here. The components that I built were these, and this particular schedule tool here, which is using a library called Daypilot, and it basically provides functionality that's very base that produces a calendar like this or a scheduler like this, and then you can tell that particular library, well, I want it to look this way, very much like our components do, but at a less a level where you've got access to greater functionality sometimes. So explaining this component, this lives within another Formbird component by itself, and that is the API or interface to Formbird. We load in this library, and then we tell it what we want it to do. I want it to set up a timeline across the top and set up a set of assets that can be booked down the side. I want that timeline to be flexible, so I want to be able to tell it, say, to go and look at hour lots, half-hour intervals, or day intervals. I tell it that if I scroll forward on it, I want to be able to go back to where I was. I tell it if I want to go to a specific date, I can do that. So this is all functionality that has to be built to tell this component what to do. Okay, so if I want a specific resource, I'll build a filter that can filter the resources, and the same for events. So this is called an event on the calendar, and I can get events that are events for me, System Manager. Some extra functionality that I've built for this is, you'll notice that there's a little legend here. There's a count of hires in the last 3 months down the side, and an asset which is struck out. This indicates the asset's in repair. How I determine that is that if there's an outstanding work order for it, one that's not completed, it'll strike through that asset name on the way. Okay, as mentioned, these are events. The green ones are events that are coming. The red ones are the events that are actually active at the moment. The grey ones are events that are allocations for commuter use. So a car might be sort of available throughout the day, but unavailable for specific times because it's been assigned to somebody for them to drive home, for example. So the grey ones are commuter use type of arrangements. This calendar would be used to book a car simply by selecting and dragging on the asset that you want to select or want to book. It then populates some of our components. So this component that I built can talk to other components that are standard components. It brings in the asset detail, who requested the booking, their phone number, when the booking is going to start, when the booking is completed. This is all editable, so I can put in a note. It also brings in from various other parts of the application who's responsible for that asset and who that asset is allocated to. So in Fleet, there's various levels of responsibility for the asset, and this gives some information on who to contact if you've got questions about the asset. So is it available for this time, or in the instance of it might be in repair, when will it be available for not when will that repair be finished, so I can book it then. This responsible person, Adam, hasn't got a phone number on his account, so that field's blank, but there's an email there, so that draws out from the account. Once I've got that information, I can create a booking, and it will add that to the calendar. It's added there. The other functionality of this is that you might want to say, hold on a minute, I've booked that for the wrong time. I can move that and then update. I can drag it for longer times. It updates the time and update. There's a couple of other functionality built in here. There's a couple of tick boxes here which automatically commence and close the booking. So somebody needs to manage, or something needs to manage the actual booking itself to indicate that it's started and completed. So that can be a manual process. So you can go to the document and update the document yourself, saying, okay, well, my booking is now commenced, or the system will do it for you and automatically commence and close the booking based on the dates it was available that were outlined for the booking, and it'll do that. So this is automatically started because the time has passed, and that will disappear from the calendar once from the scheduler once it's finished. So if we scroll back in time, there's nothing backwards. Now these produce documents, which are internal hire documents. And this is just a record of the hire event, basically. And when this loads, it loads with current information here until it's closed. So you see the asset has been in reserve status. Once the hire starts, it'll be on hire or something similar. And once the status finishes, it'll be closed out. And there's a record of that. Oops, happened there. How do these assets? We have what's called a pool. A pool is an asset vehicle document, a document that describes who's available for which asset. So if you're a member of the pool, me, I have access to these assets. If I take myself out of this pool and reload, I'll only have assets to the other pool because I'm in both pools. An asset can be in more than one pool, and a person can be in more than one pool as well. Pools can be made inactive, in which case the whole set of information disappears from the calendar. Now, what happens with those documents? We've got a set of documents that we can work with now. I've made some basic reporting. So analysis. This is another component that I built, a graph component which uses a library and presents it within Formbird based on the data that that's available. So I can see here, this is a asset hire per driver. It describes how many asset hires over what time and who was assigned, who hired them. So this one's got me at 168. We can do some smart things like filter this graph for just certain pools, which doesn't appear to work right now. Don't you love it? And we can include or exclude commuter use for this. Okay, I reckon I'll narrow this one. This is a complete list of hire documents. And now, how do we then get what happens on the asset when this thing's on hire? So we'll go back to an asset. This is another component that I built, which is just a set of buttons which scrolls to where you want to be. Reflected on the asset is the hire documents. The asset is currently available for hire, so when that hire either starts or stops, it will change the status here. We have a set of available for hire days, which controls the creation of the commuter use. When a hire is created, there can be an email sent, so we can send an email to the responsible person or the allocated driver or both. And that email can include, if I'm responsible for a particular asset, it will include the bookings for the coming week for the complete asset. So that email looks like this. So it gives you a list of the assets that you're responsible for and who will be using them throughout the week. It's kind of handy for people who have commute use. You know, my vehicle is not going to be available in these particular times. That's what I meant to say too. There's some smarts built in here so that you can't cross book. Won't allow that. And I think with cross dragging as well, you won't be able to drag it over another one. Allocations. So if the asset is allocated to a particular person, as mentioned, it will generate commute, and it's allocated as commuter use. We do that by creating an allocation document. We give it an allocation type, allocated to, and this is the critical thing for an allocation document to create commuter use documents, is really tick this here for commuter use. It will go away and it will create those documents in advance up to 4 months, and it always keeps 2 months of commuter use documents in advance. So once 2 months worth has been completed, well, there's only 2 months left, it will generate another 2 months. So there's always 4 months worth of it's always booked out 4 months in advance. And that's variable too. The booking documents take quite a while to generate. You have to generate one for every day, and it's 4 months is 125 odd documents. So I won't demonstrate that here, but this will generate those documents. It will not allow an update to the commuter use while that process has been generated. It does take quite some time, but you don't need to leave it running. You can just exit the form and do it behind the scenes. Now, why did I build this component, and why not use a standard component? We have a standard component that is a roster control. It doesn't have some of the functionality that I've been able to exploit from the library. This control might indicate to some of our component development team what might be necessary for others, and they oftentimes see that the components end up as inheriting some of the functionality that some of the other developers have put into their own components. So we take ideas from everywhere, and whatever that idea might be that works for, say, fleet, might end up back in the component if it can be generalized enough out. So, for instance, this strike-through feature here, where something's booked, that's pretty specific to fleet. We might not have that for every other application. So that might not be included in, say, a generic version of this. Something that may be included in roster in the future might be these filters or the now button or something like that. So we take these ideas and we collect them all and improve our components that way. But that doesn't stop people moving forward with specific. If there's a specific set of functionality, it doesn't stop people from moving forward with their ideas and with and being able to create what they need for their specific application. Any questions?
If I've got one for Paul Arkle. Just on the vehicle selections, is there any way of showing if it's like a diesel or an EV or a plug-in hybrid?
Yes, we can do that. Was that Chris, was it?
Yeah.
Let me just share the screen again. I have a, I didn't demonstrate this, but I have a little floaty box here that I can put in extra information about the asset. So you can see that this has been, this is grabbing information off the, off this document, but available. I've loaded basically all of the assets that are available here into the form. So all of the asset information is available. So I can just update this to put in that type of information, Chris. Yeah. So if it's on the asset, so you just have to figure out where it's coming from on the asset, where it's recorded. And I can grab that and put it on there. Yeah, sure.
Cool. Sounds great.
Yeah. Well, I hope, thank you, Paul. That was great. I hope everybody has had their fill of our show and tell, and had a chance to maybe imagine how some of these implementations would work in their environment. So I guess I'm going to say thank you for everyone. Thank you to Paul. Thank you to Adam, and thank you to Grant. Also, thanks, Mark, for your explanation of constraint-based optimization. You won't be fast-forwarding through that one because it was pretty dense. So we'll wrap it up exactly now on the hour. Thank you, everybody, and we'll see you the next time. I'll make a video, obviously a video upload of this, so that if you missed it or if you want to watch it again, and send out a reminder next week to go and to check that video out. So thank you very much, everybody. And we'll see you later.